What if I told you everything you've ever seen, every planet, every star, every galaxy, only makes 5% of the universe? The rest of it is invisible. Dark matter is an invisible substance that does not emit, absorb, or reflect light. It is undetectable. But the real question is, if it cannot be detected, then how do we know that the universe is made up of 27% dark matter? Well, it is true that we cannot see dark matter, but we can see its influence on normal matter. Normal matter is everything we can directly observe, such as planets like Mars and Jupiter, and others in our solar system. We can view normal matter with our own eyes or through a telescope, and normal matter is only 5% of the universe. But dark matter influences it by giving the gravitational force needed to hold galaxies together in their place, keeping them rotating and causing light to bend around them. Now you must be thinking, if 5% of the universe is normal matter and 27% is dark matter, then what else is there in space? Well, it is dark energy. And this is our wild guess, the only explanation from scientists right now about what else the universe is made up of. Dark energy is approximated by scientists to be 68% of the universe, and we know even less about it than dark matter. But something like dark energy must exist to explain how the universe keeps expanding. Dark energy is our only explanation, and yes, it is our best guess. The composition of space just goes to show that we do not actually know what's out there, and one such example that proves this is the Pandora's cluster. Pandora's cluster, also known as Abell 2744, is a galaxy cluster. Galaxy clusters are hundreds to thousands of galaxies held together by gravity. They also include hot gas and large amounts of invisible dark matter. But Pandora's cluster is a monster of monsters. It is the result of four different galaxy clusters smashing into each other over 350 million years. Think of it as a cosmic traffic accident. But instead of cars, you've got galaxies colliding head on and hundreds of thousands of them. But what is inside this mess? Surprisingly, about only 5% of the cluster is made up of stars and galaxies, the stuff we can actually see. Around 20% is hot gas that glows in X-rays, scattered all around from the crash. And the rest? A staggering 75% of the cluster is dark matter, invisible, untouchable. And yet, it makes up the bulk of the mass that's actually holding the entire wreckage together. That's already mind-blowing, right? But here's where it gets really wild. In normal physics, when you slam two giant structures together, everything gets mixed up. Stars scatter, gas gets shocked, slowed, and heated. But when scientists looked at the Pandora's cluster, they noticed something weird. The galaxies behaved one way, the hot gas behaved differently. It slammed together and got stuck in the middle, glowing in X-rays. But the dark matter, it passed straight through unaffected. It didn't slow down. It didn't crash. It just kept moving, as if the collision never happened. It is like watching two people bump into each other in a crowded room, while a ghost just walks straight through them. That is what makes dark matter so mysterious. It doesn't absorb light, it doesn't reflect it, we can't directly see it, and yet we know it's there because of its gravitational pull. In fact, if there were no dark matter in Pandora's cluster, the whole thing would fly apart. The visible mass isn't nearly enough to keep it all bound together. It's only because of the invisible gravitational glue of dark matter that this chaotic cosmic pileup still exists. Now enters the James Webb Space Telescope. With its incredible infrared vision, Webb joined forces with scientists studying Pandora's cluster as part of the Uncover project. The Uncover project is short for Ultra Deep Near-Spec and Near-Cam observations before the epoch of reionization. Basically, it's Webb zooming in to uncover details from the universe's early history. What Webb saw was nothing short of breathtaking. It stitched together a massive mosaic of the cluster, creating one of the most detailed infrared views ever captured. Instead of just seeing galaxies in Pandora's cluster, Webb revealed hundreds of galaxies hiding far behind it. But how is that possible? The answer is gravitational lensing. Remember that I mentioned at the start of the video that dark matter causes light to bend? That is one example of gravitational lensing, and one of the main reasons we know it exists. Gravitational lensing is when a huge object in space, like a galaxy, bends light coming from something behind it. This makes the background object look stretched, brighter, or even appear in more than one place. Think of it like space magnifying glass. Here's how it works in the Pandora's cluster. Pandora's cluster is so massive, its gravity literally bends space-time. That bending acts like a magnifying glass, distorting and amplifying the light from galaxies far behind it. If you've ever looked at objects through the bottom of a wine glass, for example, you've seen how light can bend and stretch things. The cluster does the same thing on a cosmic scale. It takes galaxies that are otherwise too faint and too far to ever see, and it brings them into focus for James Webb's cameras. And that is where the real shocker comes in. Thanks to this lensing effect, Webb spotted 83 tiny galaxies from the dawn of the universe, from a time when the universe was less than a billion years old, barely 6% of its current age. Now that might not sound much, but here's why it is incredible. Those galaxies weren't supposed to exist in the form James Webb found them. According to standard model of cosmology, galaxies that early should have been small, messy, and struggling to form stars. Instead, Webb saw compact, energetic galaxies, little star factories pumping out new suns at a furious rate. Think of it this way. It is like walking into kindergarten and finding a bunch of kids running billion-dollar tech companies. By all logic, this shouldn't be there yet, but somehow they are. Out of those 83 galaxies, Webb was only able to study 20 of them in great detail, breaking down their light to figure out what they were made of, how fast stars were forming, and how old their structures really were. These galaxies, small but mighty, may have played a huge role in the early universe, helping to clear out the hydrogen fog after the Big Bang. So how does this challenge science? Because these observations don't line up neatly with our current models of physics and cosmology, if galaxies were forming this fast, this early, and in such numbers, it suggests that our timeline for how the universe evolved might be off. Maybe dark matter influenced galaxy growth differently than we thought. Maybe our understanding of how gas cooled and clumped into stars is incomplete. Even more puzzling, the fact that dark matter seems to behave so independently in collisions like Pandora's cluster raises new questions. Is dark matter truly just cold and collisionless? Or is it something else, some hidden interaction we've missed? These are not small tweaks. If our assumptions about dark matter are wrong, that would ripple across cosmology. It would mean we need to rethink how galaxies formed, how the cosmic web was built, and maybe even how the Big Bang unfolded. And here's the big picture. Pandora's cluster isn't just a pretty image from Webb, it is a cosmic laboratory. By studying it, astronomers can map the distribution of dark matter, test how well our simulations really match reality, and maybe uncover new physics. The strange separation of dark matter from hot gas is a crucial clue. It suggests dark matter really does behave differently from normal matter. But whether that means it's a brand new particle, a whole family of particles, or something even stranger, we still don't know. And every time Webb looks deeper, it finds more galaxies that seem to be bending the rules. What if it's just the beginning? What if clusters like Pandora's are common and the weird results are actually the norm? That would mean our picture of early universe is seriously incomplete. Well, that is not just a discovery, it is a challenge. A challenge to everything we thought we knew about physics, galaxy formation, and the hidden scaffolding of the universe. If one clusters of galaxy can already bend space, reveal invisible matter, and shatter our expectations, what else is out there, waiting for Webb's golden mirrors to uncover? Because if Pandora's cluster is this strange, maybe the real Pandora's box hasn't even been opened yet. Let me know what you think in the comments. And as always, thanks for watching.